Have you ever tried to teach a programming concept only to find your student either confused or bored? I have, and more often than you might think. I'm Bruce, and we are Grokin. In an earlier Grokin, you heard me teach about the concept of CRC. Well, here's the constructor, the first C. This is actually one reducer called move. That's the next C. And this is the converter. And I'll talk a little bit more about this one in a second. The job of the converter here is the most important one for this video, because what we're trying to do is to help the programmer visualize what's happening here. Okay. So I can demonstrate this program by just saying point.new, and then I could feed it a couple of an X and a Y. Maybe this is the origin. And you can see that this creates something that's convenient for computation. And now I can use my move reducer to move this thing around. And so I can pipe this into point.move north. And then maybe I say point.move east. Okay, I have a couple of I's in there, and you can see that I've moved one north and one east. But these couple of numbers really don't show me very clearly what's going on. And so what I'm going to do is throw in an extra little feature. This might be something that's beyond my programmer's ability to create, but that's okay because I can set up their ability to do this within the project. In this case, I'm letting them wire to an existing host that already has some of the code built in. So I'm using Elixir's distributed properties to wire to a project that already knows how to render this thing, in this case with an SVG. So let's take a look at what this is going to look like for the user. So maybe I say, okay, create the point, then they can see what the data type looks like. And then I could say, okay, let's pipe that to point.show. Even though they didn't create this, we can use this to help the user visualize what's happening. Right? And now I can jump here into the middle of this pipeline, and now I could say point.move north, and watch what happens to the point. And it jumps up, right? And so now I could say point.move east, and the user can move the point around one little step at a time, and they can quickly visualize what's happening. They can understand that this concept is a transformation. And I'm not limited to just one type of visualization. So for example, here's a more layered robot that's created actually by my students. And there might be some things that I might quibble with. So for example, this map might be piped to the function save history, but I'm not worried about that. I'm really more concerned with the overall architecture of the system. And in this case, we can actually do the same thing. We could say robot.new. And then they can see this robot. And then you can see where I'm going because this show function actually knows how to work with full robots as well. I don't need my students to be able to understand how to shape this thing. I only need to be able to give them a tool that helps them do some visualization. So I could say, for example, robot.show, and then they could see the robot and the orientation that this thing is pointed north. And indeed, I can see that the heading is north. And maybe I can move this thing forward one. So I could say robot.forward. And then they could see the robot move forward one. And now I could say robot.right. And the robot turns to the right. And then I could say robot forward again. And the robot moves forward. And you can see that this is a little bit cluttered. That doesn't matter. It doesn't have to be a perfect visualization for our users to understand what's going on. So when you're asking a programming student to learn an important concept, give them a little bit of help. Help them visualize what's happening with some type of visual aid that you can even build into your tooling. This is Bruce, and we are Grokin.